In software development, understanding both what a system does and how it does it is crucial. The what is defined by functional requirements, which describe specific features like user authentication, data processing, and reporting. However, just as important are the non-functional requirements, which focus on how the system behaves under various conditions. These quality attributes include performance, scalability, security, usability, and more. While functional requirements ensure a system performs its intended tasks, non-functional requirements ensure it does so efficiently, reliably, and securely. A system that meets functional requirements but fails in non-functional aspects may be technically correct but practically unusable. Performance is one of the most vital non-functional requirements. It refers to how fast and efficiently a system responds to user actions or processes data. For instance, a banking application may be expected to complete transactions in under 2 seconds. Performance is often measured using metrics such as response time, throughput, and system latency. Tools like load testing and stress testing help verify that the system maintains acceptable performance even under high user demand. Poor performance can lead to user dissatisfaction, lost business, and damage to brand reputation. Scalability is the system's ability to handle increasing workload, such as a rise in user numbers, data volume, or transaction frequency, without a drop in performance. For example, an e-commerce platform should be able to handle millions of users during sales events like Black Friday without crashing or slowing down. Scalability can be vertical by increasing hardware capabilities or horizontal by adding more servers. It ensures the system can grow with the business needs and is often tested through capacity planning and load simulation. Security is a critical non-functional requirement that ensures a system is protected against unauthorized access, data breaches, and other cyber threats. For example, a health application must encrypt sensitive patient data and implement access controls. Security requirements can include data encryption, user authentication such as multi-factor authentication, role-based access control, and auditing. These are validated using security assessments, penetration testing, and compliance with standards like OWASP, ISO 27001, and GDPR. Without strong security, systems risk not only data loss but also legal consequences and loss of customer trust. Availability measures the extent to which the system is operational and accessible when needed. High availability systems are expected to have minimal downtime. For example, a cloud-based email service may require 99.999% uptime, which allows for just a few minutes of downtime per year. Availability is supported by redundant infrastructure, failover systems, and regular monitoring. Metrics such as mean time between failures, MTBF, and mean time to repair, MTTR, help organizations monitor and improve availability. So, reliability is closely related to availability and refers to the system's ability to perform its intended functions consistently over time without failure. A reliable system maintains its operations accurately and without interruption, which is essential for mission-critical applications like air traffic control systems or hospital software. Reliability is evaluated through error rates, system uptime, and recovery procedures. Backup strategies, error detection, and fault tolerance techniques are commonly used to improve reliability. Maintainability refers to how easily the system can be modified, updated, or repaired. As business needs evolve and bugs are discovered, the ability to make changes quickly and safely becomes crucial. Maintainable systems are built with clean, modular, and well-documented code. For example, a requirement might specify that critical bugs must be resolved within 24 hours, or that new features should be deployable with minimal disruption. Maintainability can be assessed by measuring code complexity, the time required for changes, and the frequency of failed updates. Usability focuses on how easy and intuitive it is for users to interact with the system. An application with high usability enables users to complete their tasks quickly, accurately, and without frustration. For instance, a ride-hailing app should allow users to book a ride with just a few taps. Usability is evaluated using user feedback, task completion rates, error rates, and user interface design standards. Accessibility is also a part of usability, ensuring that people with disabilities can use the system effectively. Portability describes how easily a system can be transferred from one environment to another. This may involve moving an application between operating systems, like from Windows to Linux devices, such as from desktop to mobile or cloud environments, for instance, from AWS to Azure. A portable system minimizes the effort required to support multiple platforms, which is crucial in today's multi-device world. Portability is assessed through installation testing, platform compatibility checks, and environment abstraction techniques. Interoperability refers to the ability of a system to work with other systems or components. Most enterprise environments involve multiple applications that need to exchange data or coordinate processes. For example, a university management system may need to integrate with a library database, student portal, and payment gateway. Interoperability is supported by standardized data formats such as JSON and XML, communication protocols like REST or SOAP, and API contracts. It is often validated through integration testing and system interface documentation. Compliance ensures that the system adheres to laws, regulations, and internal policies. This is especially critical in regulated industries such as healthcare, finance, and government. For instance, applications that handle credit card transactions must comply with PCI DSS standards. Similarly, applications serving users in Europe must comply with GDPR for data privacy. Compliance is ensured through audits, certifications, and adherence to relevant policies and standards. Localization and internationalization are non-functional requirements that support the global usability of a system. Internationalization involves designing a system to support multiple languages, regional settings, and cultural formats. Localization is the process of adapting the content for a specific region. For instance, a global retail app should display content in the local language, support local currencies, and follow date and time formats based on the user's region. These requirements are validated through multilingual testing, cultural review, and region-specific configuration. In conclusion, non-functional requirements are crucial for delivering high-quality, scalable, and user-centered software. While functional requirements define what a system does, non-functional requirements define how well it does those things under real-world conditions. They address the qualities that make a system reliable, secure, efficient, and pleasant to use. Ignoring NFRs can result in systems that are difficult to maintain, fail under pressure, or pose security and compliance risks. Therefore, integrating non-functional requirements early in the development lifecycle is essential for building successful, sustainable, and user-friendly software products.